Challenges in renewable energy integration and grid synchronization. Renewable energy has become a key part of our global energy transition. But as solar and wind penetration grows, integrating these resources into the power grid brings serious synchronization challenges. In this presentation, we'll explore the major issues affecting grid stability, infrastructure, and operations. Key challenges. The challenges can be grouped into four main categories: variability and intermittency of renewables, grid stability and power quality concerns, infrastructure and control limitations, and finally, operational and economic complexities. Each of these creates unique hurdles for grid operators. Variability and intermittency. Unlike traditional power plants, renewable sources like solar and wind depend on weather conditions. This means their output is unpredictable, leading to fluctuations that don't always match demand. These sudden changes create grid instability and require constant balancing. Grid stability and power quality. Most renewable energy is inverter-based, which lacks the natural inertia of synchronous generators. Without inertia, the grid becomes more sensitive to frequency changes. On top of that, high renewable penetration can cause voltage imbalances, harmonic distortions, and flickering. Inverter systems also face difficulties during faults, often disconnecting instead of supporting the grid, which increases the risk of cascading failures. Infrastructure and control limitations. Many parts of our power infrastructure were built decades ago, designed for one-way power flow from large plants to consumers. But renewables are decentralized and bidirectional. This mismatch creates stress on aging systems. To cope, grids need advanced monitoring, real-time control, and smarter analytics. Energy storage is also a major gap. Without it, excess renewable power can't be saved for times of low generation. Operational and economic concerns. Finally, grid operators face complex operational and economic challenges. Balancing supply and demand becomes much harder with unpredictable inputs. Two-way power flows from millions of distributed energy sources require entirely new strategies, moving beyond the traditional control room models. This increases both technical and financial complexity. In summary, renewable energy is vital for a sustainable future, but its integration into the grid comes with significant synchronization challenges. Overcoming these will require upgrades in infrastructure, smarter control systems, expanded storage, and innovative operational strategies.